Oh hey, look at that. It's a surprise stream. It's been like ages since I did one of these things. I hope people can hear me. I'm not 100% sure. I'll most likely assume this is, and I'm also pretty much going to assume people aren't really going to watch this live. Anyway, F# 9 is coming next year, and one of the big buzz things is going to be like analyzers, and there's the Analyzer SDK, and recently on Amplifying F#, which is a sort of a community stream that I help facilitate from time to time, there was a session about, well, writing F# analyzers today, where sort of David and I sort of went over the Analyzer SDK project. Long story short, it's totally possible to write F# analyzers. It's not always that hard. Let me just grab the SDK real quick. So this is the Ionide F# SDK. There's some good stuff in there, and basically this is just like the building blocks library, and then we're also going to create like a community project to have some implementations on Ionide analyzers. This is all very brand new stuff, so this video is going to be raw. There's no script in here. I'll just see it as I, just spin it, wing it, you name it. And yeah, we'll just give it a try. So this is all very brand new stuff. This isn't even on NuGet yet. It will land in a couple of weeks. And well, the clue is that this sort of is a community, repository for analyzers. Like if you have an analyzer idea, if it really is something that we all agree it's good to check these things in your code, but you don't want to have the burden of maintaining a actual project that you ship on NuGet, this might just be like the good sweet spot for you to sort of contribute to that, get it in your own code, but not have to worry about keeping it alive forever, because well, we all benefit from things like that. So I'm gonna, not gonna explain every little single thing, so a lot of stuff might be, rather newish. I just felt like doing a stream because it's a long time, and I'll just be creating an analyzer. This is pretty much just to wrap up the end of my day. There's an issue over at .NET F# repository to sort of get ideas for the Analyzer SDK. What does it need to do? And one of them is a suggestion from Gauthier, which basically says like, hey, if you could the compiler tell me that I'm not using a name for all my fields in a DU? So if it's okay if you like have one field, it's okay if all the fields are named, but it is not okay if you like one is named and one isn't and the other is, and that's more or less the type of thing you want to warn about. And truth be told, I do kind of agree with this. Like from like a tooling point of view, it's just all a little bit more nicer when you give these things a name. And well, it also just isn't super hard, I believe, to like implement. Like how can we easily test this code? And yeah, that's what I'm aiming to do in this little stream experiment thing. Well, we'll just get right into it. So I downloaded my fork of the repository. Let me quickly go to presenter mode. And, I'll just assume you kind of are able to follow along, but I'm aware that this is all brand new stuff. But yeah, let's just create like a new branch named fields. And the first thing we're going to do is we're going to create an analyzer, and what this could be is like, I think it fits the suggestion category maybe, or maybe it's a stylistic thing. So yeah, this is a bit of going to be a bag of different kind of analyzers, so there's no real set in stone thing about, oh, it's this category or it's this label, or this is all very early days. We just put them in a bucket for now, and I'm pretty much just going to create like an analyzer under suggestion here, and unnamed discriminated union fields analyzer. That sounds like a good name. Unnamed DU. Oh, it's tempting. Discriminated union field analyzer. Pretty sure I got that spelling wrong, but the point is, we're just gonna do the code, and like in a bit, this will be, be very sensible of what we're doing. Now, there's no real template for an analyzer, but what we basically need is a function that takes in the CLI context and then just returns an async, which returns a list of messages. For now, let's just maybe copy this and then rename in the process. And yeah, someday maybe we might have a template for this. But as I said, this didn't exist until like this week. So in any case, let's say that the wording or the description verifies each field in a union case is named, something like that. And this will be error code 4. How do I know that? Well, there only are 3 other analyzers, so that's going to be code 4. We can remove the boilerplate for now and just return an empty list of messages. And that's basically the starting point of like our analyzer. Now, the context will contain information about your current file and project, and we're going to use that to sort of go over that and try and see if it's, if it should raise a warning or message or not. The thing we're going to do next is just write a bunch of tests and then sort of build our way up. So there's also a test project. I'm pretty much just going to copy, make a new test file. And I'm just going to copy a little bit of setup, the first test of the other file as well. Again, I mean, this is consistent with what's out there, and let me build that. Oh yeah, should take the same name. Unnamed. So analyzer suggestion unnamed. A little bit of setup when it comes to unit tests, but the basic gist is, well, we need a project options. This contains all the things the compiler knows. We can sort of create the F# project options, good stuff. This just looks like a helper function from the testing package. Let's not overly worry about that, but basically we have a set of options. If we were to depend on certain NuGet packages, we can pass them here, but now that's not really the case. And here in our first function, we're going to see that unnamed field is detected. Or maybe one named fields and one unnamed fields, something along those lines. So now we're just gonna write like an F# code sample that actually should trigger the thing. So we have a bar of string and then we have an int, and because the int is not named, our analyzer should trigger. That's sort of the gist. Yes, there we go. So it didn't have the suggestion namespace. Here we go, and then let's just assert that there is one message over here and that one message contains our text. So basically context creates like an empty project with our file over here that sort of gets everything in there. Then we sort of run this to our function. Our function takes in a context, returns an async list, and we have some messages here. We're going to assert the message is there, and then we're going to assert that message also is not just, well, it's the message we expect it is. So yeah, I mean, pretty straightforward. We get some input, we're going to run it through the analyzer, and then we expect some messages as the output. That's plainly to speak. And we run this and we have our failing tests, which of course is the sweet spot. So we expected that this was empty, but it is empty, of course, as we don't have any implementation. Now, taking a look at this definition, we're basically going to circle back and take a look at how does this AST look like, because that's basically the thing we're going to have in the context. We're going to see, oh, what AST do we have, and then how can we sort of detect that there are SYN fields, and if one of those SYN fields doesn't have a name, then that's sort of what we're going to try and capture. So, we're pretty much interested in the SYN union case, and we're just going to try and create a visitor for that. So, a visitor is a way of getting, traversing the entire syntax tree, but not having to write code where you go from top to bottom yourself. But there's existing code that traverses the tree, and then just mention that you're interested in a SYN union case. We take those from the Analyzer SDK package, and I'll probably need to open a namespace. So there's this AST collecting, which is part of the SDK, which has some helper functionality. AST collecting, syntax collector base, and that's gonna be of, well, a range, and we're gonna say with, and then override the thing we're interested in. Now, I don't know by heart what exactly is already in there, so we probably want to head to the docs, API, all namespaces. So there's a little bit of documentation about all this stuff. When I go to AST collecting, collector base, walk fields is an interesting one, because it seems to be a walk field of SYN fields. But that might trigger a little bit too much, because there also are other SYN fields that are not really used in this thing. We have a walk union case, so let's take a look at that. So it's a walk union case, and it takes a union case. Union case, which is going to be a SYN union case from the compiler syntax tree. I know the compiler syntax tree pretty well by now, so I'm just gonna gloss over and act that this is all normal. It's not, but over time, it's always the same thing. So it actually doesn't expect anything. There we go, and we're just gonna create like messages in a resize array of message. We're gonna do a pattern match on the shape, and when it has our shape that we sort of see where there's something wrong, we can just I can actually destructure that. So we are interested in this case in the fields. That might be the case type. Let's take a look back. Yeah, the case type should be of SYN type. Case kind. Is it case type? SYN kind, yes. And that should be fields. There we go. If it is not a field, so I'm just gonna ignore it. If it is, then we basically wanna let's for now do a check. Are all named? Then we do something like fields list dot for all, and probably need to destructure SYN fields. There we go. And so SYN field will have ident option. So let's just say that for all ident option, option is sum. There we go. And this is a boolean, so if not all are named, then we basically want to create a message. So we then do message add, and I'll take a little peek what the message needs from another function. So it's let's maybe, yeah, let's do like a choose instead, and if it is we kind of want to have the range over here from the fields, and then we do like if is none, then we take some of the field range, and that's basically the range we're going to use inside of the message over here. Then over here we can basically do something like fields for and fields do, and then basically just add the message over here. Yeah, this is always difficult. Is this a warning? Is this a hint? I feel like this is personal preference, so let's put a hint for now. The code is for is somewhat established. Then the type is a weird one. I always put the name in there, and for a message, let's say fields inside union case does not have a is not named, or something along those lines. So this should be the range and fields. So in that same message over here will be checked, so I actually added the description in there. Yeah, but that's fine. And range, some M fields. Not quite sure. Oh yeah, fields. It should be unnamed fields. There we go. And to be honest, I think this pretty much is it. We need to, so we have the visitor, but we need to execute it. And then we can say walk AST with the visitor, and then take the untyped tree, the parse check results, and parse tree. Basically, the walk AST is another helper code from that AST collecting thing. It is going to execute. Let's just put a breakpoint here during the unit test. It's going to do this kind of a check. It's going to walk. Every time it did find something, it adds it. And then we do say seek to list of the messages. And I honestly think that should be it. So let's do a little debug. Now I'm really skipping over a lot of the magical parts, like how did it get the AST in the first place and what did the compiler do and all that, but yeah, here we are. I mean, we had our code sample, we have AST, there's a union case, this foo is coming in here. The foo will have some fields over here. Let's take a look. So the bar has a name, but then this int doesn't. And so we expect that there's one unnamed field, it creates a message, and the test is green. So yeah, that's really all there is to. So I really believe that we can do a lot with analyzers, and we can do a lot today. That's sort of the voila moment, and that's why I kind of wanted to make a little stream thing. Because, you know, let's not just talk about it, let's also just freaking write them. Good. Now let's add some more tests. Let's do single unnamed field and say this shouldn't trigger. Because I feel like that was in the description as well. If we go back over here, the example of case 1 as an int is kind of okay, which I agree. Typically this will have like a good name that definitely resonates with what the type is here, so there's no need to repeat that. So we want to check whether that is going to be filtered over here. So we just have foo of int, we get the messages, and then assert is empty messages. There we go. And again, the whole red-green refactor thing, this should be a failing test. We go back to our code, and we can just do an if named fields is empty, then return, else do the for loop. Something along those lines. Let's just run the tests again. And it still triggers. Oh yeah, sorry, not empty, but if it's only, yeah. If it only has one file, but we actually should check, this a little bit up front, so it might just be easier to like a sync case where there's a case type of a synth field with a single synth field. Yeah, basically that's enough. Like if we're in the situation where there's only a single field, then it doesn't really matter if it's named or not. I think that makes more sense. Yep, all right, there we go. Okay, so that's pretty good. What else do we have? Yeah. I guess there was also talk about exceptions. So let's just take a look. Exceptions basically are going to follow the same code path. They started an exception definition syntax point of view, but then eventually they go to the sin union case. So I don't really see any reason that this wouldn't get caught by an analyzer, but it's always good to have a little bit of regression testing. So, boom, boom. Fields exception are detected. So there's one int, then there's a string that should leave us to 1. Let's kind of just copy that again. There we go, and I just kind of expect that all to just work out. Ooh, interesting. So it is not empty, but it is empty. This could be one or two things. So either our walk union code isn't getting hit for this. Yeah, okay, that's a shame. Okay, this will be a little bit of yak shaving, I'm afraid. Let us take a look at the Analyzer SDK itself. If I can easily open that. There we go. So inside of the Analyzer SDK, there's some code that does this walking, and gut feeling it's not traversing exceptions for now. So set exception. Yes, okay, that's unfortunate. So in this case, the walk simple type, which is the thing that eventually takes your walker through this, will, ooh, look at that, great job. Yeah, so this thing like picked up the cases and walked them, but it doesn't do that for exceptions. So that's why our codes didn't get hit. Yeah, I mean, it happens. Let's just roll with it. Exception definition something, and the union case. Oh, this is interesting. Is it allowed to? Oh yeah, it is. It is. You can only have one case for the exception, but it is definitely allowed to. Union case, and we're just basically going to do walk union case like this, and that basically should, yeah, should work. So if we were to build this, and oh boy, copy path, go to the analyzer decay over here. Yeah, definitely freewheeling this one. But if we now go to here, try the add reference. There we go. No, we don't need the SDK. We're just referencing it. Might need to do the same for the test projects. Let's just use testing. Okay, not quite sure. Gut feeling is that we need both. Let's wait on the builds, see if that works out. Not compatible. Yeah. So why would that not be compatible? So I would assume that compiler service is actually exactly the same. So if we take a look at the packages prop, this version here, pretty sure that actually matches what we have over here. Pro tip, ensure that all these things really have the exact same version. Yeah. Okay. Oh yeah. Sorry, my bad. This actually recently did an API change. So the walk type AST takes the TST collector. Oh man, I should basically just yeah. There we go. Yeah, this made a little bit more sense to me that the walk TST function just takes the entire tree and you don't have to think about that, you know, the thing has declarations itself. Okay, so something along those lines. again, I know this stuff because, well, we've been working with it today, so that definitely helps. Moving back to the analyzers, if we run the tests now. One test still fails, and that is still not happening. Let's debug and try and see if it's at very least hitting that code path. Still not. Okay. So we had the SDK project here. We added it here and here. Maybe it all needs a rebuild. I mean, I doubt it, to be honest. Yeah. Union case isn't being walked. Why is that? I do wonder if this really is now the right SDK with our change over here. I do think it is, but simple definition. There we go. Even more good stuff. Yeah, this is again a little bit of compiler history here. There's this thing called the syntype definition exception and simple, and one of them isn't really real. So heading back to this guy, if you look at an exception here, it is going to be syn module declaration exception, and we'll need to check if it's really at that level that something is happening, because then there's an exception definition and all that good stuff, and that eventually gets transformed to this guy, I think. So this makes sense, but it's unclear to me if the declaration exception is processed, which might be the case. Okay, it's not. So yeah, we have our answer there. Exception definition. Well, which basically the code we had. I think it's going to be more or less, or it might be just one extra layer being wrapped in exception definition. Which has the exception representation. There we go. Curly brace, arrow. Yep. Something like this. And yeah. Still not entirely sure. Okay, this didn't rebuild. But yeah, to sort of make an elaborate point, some things in the syntax tree namespace aren't actually coming from actual syntax. They might just come from, well, other stuff. So back in our analyzer, try and run this again. Yay! Okay, that worked. So a bit of an anticlimax that there was a bit of a gap inside of the SDK and this wasn't being walked, and then, but it highlights that all these things aren't perfect yet, and it's not extremely difficult to improve the SDK. And these things unfortunately surface when, well, you encounter a problem in the SDK. So maybe we need to do some sort of easy MS build magic that allows you to easily run your local SDK and then, you know, play with these things together if needed. All right, now the last thing we'll need to do to actually get a PR is, well, we need a little bit of documentation, because just because this exists doesn't really say that much. And we're going to run the documentation locally for now. Before we do that, it's interesting that we add our page in suggestion. For the FSDocs tool, I found it to be easier if the page exists before you execute the command. So we'll just basically copy paste that, go back to our analyzer, steal the name. There we go. Index will be tree, problem. And yeah, so that's good enough. Let's run the docs. And this basically runs a bit of commands to eventually run the documentation server locally. So I have my unnamed discrimination union function. And the idea is that we have like a, what's the problem in this thing? What's the fix? So maybe let's just circle back. And this is the less exciting stuff, of course, but I feel like we should definitely add it. It is recommended that all union case fields have a name, with exception, with the exception that for a single field union case. Yeah. Triggers analyzer. Fix at the missing name. And the reason we're also like doing this is something like that. That if you have this over here, then in the browser can sort of look at this, and this link will then be used inside of a Serif report. Yeah, so while we're at it, I'll quickly go over what's a Serif report. So we made this analyzer thing, and how can we now like execute it on actual code? For example, let's do a .NET tool lists. You'll see that I have actually installed the analyzers over here, which means I can invoke the command line tool, point to a project. Let's maybe just show the help first. You can pretty much point to a project, point to an analyzer path, which is the DLL we just made, and we'll then be able to have a report, and that will then eventually get like the page we just created as part of the report, which is the reason why we actually want documentation. So yeah, we do the analyzers. We're gonna pick a project. In our case, I'll probably just run this on like some Phantoms projects because I know it well. So Phantoms core, maybe. Phantoms core, and then analyzer path. Eventually this will kind of come from NuGet or someplace, but for now we'll just take the local path, which would be the Ionide, no, source, Ionide Analyzer, spin, debug, net. Your Analyzer DLL needs to be net 6. Let's just write verbose for now. And report results.serif. Yeah, serif is basically JSON, but it's some sort of standard. And it tries to load the Analyzer SDK. No, that's not what we want. Yeah, there we go. So it loads 4 analyzers because there are 4 in the assembly. Ooh. Then that kind of sucks. There we go. Okay, yeah. Remember when we sort of tinkered with, oh, let's just fix the SDK on the fly? And yeah, I'm sort of running our binary with a local SDK version, so I should also run this thing with a local SDK version. Well, it makes a lot of sense that this doesn't work. Let's go to the SDK, build the CLI project, and then run that. Because all these things just really need to be in sync before they're binary compatible. There's like no wiggle room. Yeah, I think that's the one. So you have the exe. There we go. And it actually triggered other rules. There we go, there we go. So in syntax oak, there is a field inside a union that's not named on line 9. So let's just quickly take a peek at line 9. So head 10. That's it. That's interesting. So it triggered for this new line case, but it doesn't have any fields at all, so it shouldn't. It shouldn't really trigger on that. So let's maybe just add another test for that. Yes. So. Union case without fields shouldn't trigger. So basically, you can take the original texts. This is a relevant thing, and it should be empty. Okay, let's go back. What did I miss? No, okay, sorry. This was line, this is line 10, this is line 9, and it's the string over here should have a name, so it did actually do the right thing. Yeah, that's pretty good stuff. So there's this serify I told you, which is basically a JSON. And yeah, this is just like an industry standards, and stuff like that should be able to be processed by our CI/CD thing. So if we go to 004, I would expect it to be present somewhere. That's again interesting. Why is that not the case? Yes, maybe because it's a hint. I'm not quite sure. Let's turn the hint into an error, and then maybe that that gets picked up. Yeah, the hint thing might be a mapping. Oh yeah, I think I'm doing now. Yeah, the severity error over here, I don't think hint is mappable to what serif is, so maybe we should map hint to an info as well while we do the mapping to that serif thing. Which is yet, you know, another thing. Like, it's all little things. It's all early days. But other than that, I mean, it's pretty doable to contribute to all these things. All right, good. So now we have the rule, and then this in the results, this rule was broken, the level is error, the message fields, but then when you go to the definition, you get like the help URI, which then leads us to this thing, and then you know, oh, that's what triggered the analyzer, and that's how I fix it. Yeah. So yeah, analyzers, good stuff. There's this is already like open source, but well, the NuGet package isn't there yet. This will probably ship by the end of the week. Go check the SDK, good stuff is there. It's like the whole getting started thing, how to use them, how to write analyzers. So this really goes into some details of how this stuff works, which I glossed over a little bit, but yeah, there's really docs out there, so that's pretty good. And yeah,